Okay, let's start. Okay, announcement. Your test one will be next week, Wednesday. Next week, Wednesday. This is week 7. So next week is week 8. Your test one will be in week 8, Wednesday, 11 or 14. 11, right? Next Wednesday is 11, right? So 11 October, morning 8 to 10. Although the question was set to finish within 1.5 hours, you should able to finish in 1 hour. But I will allow until 10 a.m. right? So we'll be at meeting room 2. So at level 5, meeting room 2. And then for your lab report, you need to submit by week 12, Friday, 11:59 p.m. So if you submit after this one, I consider late submission or no submission. So you'll get 0 marks for your lab report. Okay, I won't mark after this due date. Then go to the canvas, because this is a group report. So you go to the canvas and do your own grouping. Okay, do your own grouping. And for the student that have missed the lab session, please assign yourself individually in the canvas. Don't you can use the other group member data, but for the missed experiment, you need to do your own experiment. Okay, these are the 2 announcements for today. Okay, let's recap what we have learned so far. Okay, chapter 1, chapter 2, chapter 3. We are now in chapter 3. Okay, chapter 1, you deal with displacement of position, velocity, acceleration, and time. And you deal with erratic motion, which you describe the motion of the particles by using graph. There are 5 graphs. So in your test 1, you'll be tested the graph. And then there are 3 Newton equation, which is acceleration must be constant when you want to use. Okay. Now chapter 2, you deal with chapter 2, you deal with what? What you learn in chapter 2? Chapter 2, what you learn? What you learn in chapter 2? What you learn in chapter 2? What formula you use for chapter 2? Huh? F equal to ma chapter 2 meh? Chapter 2, what you learn? Chapter 2, what you learn? What you learn in chapter 2? Okay. What you learn in chapter 2? What you learn? Huh? Okay. Chapter 2, you learn about force already. All the force equal to ma. You convert motion into forces by multiplying mass and the acceleration. And also here you learn about 2 motion. One is linear, x and y, and you learn about the collinear motion where you start to have tangent and normal direction. What else? Okay. Chapter 3, what do you learn so far? Huh? Huh? Chapter 3, you still learn F equal to ma. Huh? Work. Okay, what is work? What is work? What is work? Huh? Force times distance. Not very accurate. Okay. Work we define as U equal to force multiplied by distance. But the thing, because these are two vectors, the vector must be parallel. Then only can create work. Okay. Okay, back to chapter 2. What kind of force that you involve here? What are the force that you involve here in chapter 2? There are four kind of force, right? Weight, friction, you need normal, then external force. So these are four kind of force that in chapter 2. Okay, in chapter 3, you learn about work. So what kind of force that give you work? What kind of force that give you work, or what kind of work that you deal with in chapter 3? You deal with external force, and then what? What else? Does the weight create work? Yes, work create depend on the direction. Okay. Then what else? What else? What else? What mechanism they are seeing in chapter 3? Spring, right? They start to deal with spring already. Okay, in chapter 2, you deal with another one. It's called pulley system. Right? In chapter 2, you deal with pulley system. Then you link this pulley system in chapter 3 again. Okay. Okay, so far, this is what we learned. And you try not to confuse yourself with this one. And previous lecture, we stopped at principle of work and energy. So today we'll learn about energy, but if you use principle of work and energy, what does it mean? It means the work, the work that you done must link to uh, uh, principle of work must be linked to. There are two kind of there are two kind of energy that you learn in chapter 3, potential and kinetic. So far we learn about kinetic that we replace with capital T. Capital T. Potential, later we will represent one more symbol. So far we learn about principle of work energy with kinetic. So the change of work will equal to the change of kinetic. Or in the more proper terms, you write delta capital U T2 minus T1. And what is the equation for kinetic? Half mv square. So you replace this equation, half and v2 square minus half and v1 square. So this is delta U. So you can either write this one, this equation, when you deal with principle of work and energy. Okay, so you can rearrange any arrangement as long as you have delta U, T2, and T1. Okay, so if you look at this one, if when you need to use the potential and kinetics, later I'll show you the potential question. If the object moving with the velocity or acceleration or this with distance or time, then it will give you V. When this object move, it will sure create energy and also the work done when it's travel. Okay. All right. Later we'll look at potential today. So later, this principle of work energy will be a bit complex. You will have not only consider kinetic, but you consider potential. So I'll give you the hints for how to solve this one. Okay. So today we go into another one. It's called power and energy. Power and efficiency. Now, what is power? Power is the rate of work. The rate of work. So what I mean by rate of work? You take the changes of work here. When you do power, power equal to du dt. Meaning, when you go into power, sometimes your energy will be in the equation form. You need to differentiate this one with time. Then it becomes power. Okay. So engine dynamics will not be that direct as you did in statics. Engine dynamics, you deal with linear equation, quadratic equation, and polynomial equation. Then you need to do differentiation. But the whole concept for power is du dt. It's the rate of changes of your work. Okay. So you know that work is force multiplied by the distance, and both must be in a parallel direction. Right? So du equal to F dot dr. You put inside there, right? P equal to du dt. You substitute your du as F dot dr dt. You pull your F out, because normally force will be constant. But if force have equation, you need to also carry your force together. But this is dr dt. So dr dt also equal to velocity. Okay, dr dt also equal to velocity. So F dot V will give you power. So power, the F will be Newton, velocity will be meter over second. So power have two equation, power equal to du dt, or you can use force multiplied by velocity. The unit will be Newton meter over second square. So it's a Newton meter second. Newton meter also equal to energy or joule. So it can also be joule per second, right? Or watt. Okay. So joule per second, this one equal to watt. To watt. So you learn about electric circuit in one of the module, right? So you calculate power. So 1 watt equal to, or this is equivalent. Okay. So efficiency is a ratio of between your input and output, right? So efficiency, you take your output divided by input. Efficiency equal to output divided by input. But this one, we take power lah. Efficiency. Okay. So this is a concept, right? What is the maximum value for efficiency? What is the maximum value for efficiency? 1. Okay. So 1 is the ideal case, but on this earth, there is no 100% efficiency. Okay. Because you deal with friction, you deal with drag, you deal with resistance and all this. So it can be energy, it can be power, as long as you take output divided by input. Okay, let's look at example number 6. So example number 6, you have a man pushing a box, a crane given you a mass of 50 kilogram with a force of 150 Newton at a certain angle. And this angle was given you in the trigonometry relationship. All right, 3, 4, 5. Determine power supplied by the team when the time is 4 seconds. Coefficient of kinetic friction between the floor and crane is 0.2. Initially, crane is at rest. So when you see power, when you see When you see power is fall under chapter 3. Power is work divided by time. So you need to call out all the equation that we write on the whiteboard here. So basically, you convert the info that you know. So you have mass. So first you start with free body diagram. Your focus is on the crane. So you draw your free body diagram. You start with the center of your mass. Draw down, write capital W equal to mg. An external force at a certain angle. This one is 345 with the force of that. Then what else you need to add? What else? Huh? Before friction, what you need to add? Normal force. Why you need to add normal force? Because there's a contact. As long as any object contact with surface, there is a normal force. Normal force will give you friction. Where is the direction of friction? Go to the left or right? Left, because you're pushing that way. Pushing to the right, the friction will be opposite of this one. Okay. Okay. You are given mu k 0.2. So write friction equal to mu kn. Okay. So this is 1 mark. This one, 1, 2, 3, 4. Maybe here already 4 marks here for your diagram. Okay. So next one, what you do, it asks you determine power. So you write power definition. Power equal du dt or force and velocity. Okay. Then it gives you time. Time 4 seconds. Okay. Initially at rest, u0 equal 0 ms. Okay. Draw free body diagram as what we did on the whiteboard. Okay. Then you determine the work done by the object. Okay. So this is the one that you see on the screen here. This one is F equal to ma. So there's a kinetic diagram on the diagram. So beside that, you draw the A to the right hand side. It's a combination of two diagrams that you learn in chapter 3. In chapter 2. Okay. So you carry chapter 2 things into chapter 3. Only different is you are calculating power. Okay. So once you have that, you convert all your work, all your force into work. So you do calculation to calculate all the unknown first. You don't know about your n. So you need to do calculation for n. Okay. So how do you do calculation for n? Go back chapter 2. Same procedure. You write F equal to ma to find the n. So F, what are the forces you have in y? And W is what? Positive, negative, negative, positive n, negative W. What else? How do you convert this one? 5 what? But not 5. Force multiplied by By what? This is the force. You want to split into what? This one and this one, right? So this one is what? Force what? This one is what? Sine or cos? Sine theta and cos theta. So you are given the number here, 3, 4, 5. What is sine? How you calculate sine? 3/5. How you calculate force? Cos? 4/5. Okay. Of course, if you want to go to find the angle here, also can if you do. But it's the same thing. So you put in all the force in one on the left. So force on the left and then my. What is the What is the ay in this case? What's the ay? Huh? What is ay value? What is the acceleration in y direction? Huh? Ay or what is ay for this box? Y0? Huh? Yes. It doesn't move inside the floor. So 0. Yeah. So on the right will be 0. Please pay attention. I don't want to see you next semester. Please pay attention. Okay. So there's only one unknown in this formula. This is chapter 2. This side is chapter 2, not chapter 3 question. Chapter 2 question. So you find your n. The purpose of finding n is to fix your friction. So in your x, so all convert to x. So here also same, got one x positive, this one negative, and no more. So you have two external force and the friction minus and max. Okay, so from here you know your ax because all the value you have already. Okay, so once you know about the F equal to ma, you have all the unknowns value in your free body diagram. Okay, understand the concept first. Don't chase after the numbers. Right. So first step in solving any engineering dynamics question, you need to know how to draw free body diagram first. Draw the free body diagram, then look into the question. Identify this question is which chapter? Chapter 1, chapter 2, chapter 3. Each chapter have their own formula. So in this case, you combine chapter 2 question. You know that this is chapter 3 question. So chapter 3 question, you need to combine with chapter 2 equation. Like example, this one. You need to combine F equal to ma to find the missing parameter. In this case, n is missing, acceleration is missing. Okay. So when you start with chapter 3 equation can, but if chapter 3 question equation cannot help you, you go back to chapter 2. Try to think chapter 2 any equation that can help you. If chapter 3 cannot help you, go to chapter chapter 2 question cannot help you, go to chapter 1 question. Chapter 1 equation. Normally, when you cannot solve chapter 3 equation, you go back chapter 2, you reverse back to chapter 1. Normally, chapter 1, you'll find constant acceleration. You'll need to use the 3 Newton equation. Okay. So once you find all the unknown, because acceleration is constant, you can use the chapter 1 3 Newton equation. So one of it is velocity. So you have the time, you have the acceleration, you have the initial velocity. So substitute the value, you find the final velocity. Final velocity, then you have the force already. But the force must be parallel to the motion. You have your V. This V is along x-axis. Okay. So power supplied by the man will be F multiplied by V through the derivation just now. So, and then this one is must go along the motion. So in this case, we are using Fx direction and multiply by the Vx, V velocity in x direction. Same, huh? Okay. So Fx equal to F cos theta, V, and then you substitute all the value, you get the power. The answer is 37.4 watt or 37.4 joule per second or Newton meter per second. Okay, remember the unit. You don't calculate, then give me one numbers. You only get half of the marks. Let's say the answer is 2 marks. If you without the unit, you only score 1 mark. Okay. In the calculation, in your calculation steps, actually I don't care about the unit. But when you arrive at certain value, for example, the n, you need to write the n equal to how many Newton, acceleration equal to meter over second square, velocity equal to meter per second, and so on. I don't care anything about the inside the calculation. But the final answer, please give the unit. Okay. Next is the application in the industry. So when you go to industry, you deal with motor and all this. Motor, they supply in watt, right? In energy, in joule. So let's say you have a crane system. Motor M hoist lift a mass 35 kilo crane. So that the acceleration at point P here, there's acceleration here. The acceleration here reach 1.2 meter per second. Meter per second square. Typo error here. Right? The acceleration is 1.2 meter per second square. Typo error. Determine the power that must be supplied to the motor at the instant P have velocity 0.6 meter per second. Cable and take this is efficiency is 85%. Okay. So when you see this kind of question, it's actually it asks you to write what you understand about the parameter. First, you see the efficiency. You write efficiency equal to what? Power output divided by input. Then you write what is power. Power equal to force velocity or du dt. You only write du dt when you see the change of when you write when you need to write du dt when you see u in the equation form, then you write this one. Like u equal to something like 4t plus something, then you write this one. If you don't see anything about the u equation, you straight away write p equal to fv. Okay, then you have an acceleration. You have acceleration. So once you see acceleration, sure it will be in chapter 2 already. F equal to ma. So acceleration is given. Velocity also given. So velocity you can link to here. You can link to here because this is Fv. So you have the okay. Now you need to find the force. Okay. Now here you are given the datum. You are given a pulley. Okay. So you need to when you see pulley, you need to you need to pull out the steps in analyzing pulley. When you see pulley, the first step is what? Find the total length of the rope first. LT equal to what and what. Second one, dLt over dt. Change it to velocity. change to velocity. So from here, you able to find the differences between A and B. Then from here, you d something again, it become acceleration. Okay. So you have the datum here. So datum positive go down. Datum number 2 go here is positive. So this is a rope system or pulley system. When you pull towards the motor, what will the pulley move? Where will move up, right? So you will get positive and negative relationship in the velocity based on the datum. So this is a combination of chapter 2 question combined with chapter 3. Okay. Then the rest you find the missing parts. From here you have A and B because you are given acceleration are given and you are given velocity over here. So here you label as, let's say this is A, this is B. So when B move, A as this also will move. Okay, you need to find what is the ratio between the two. Okay, then you are given the mass of here. Is go back to your statics chapter. You draw the pulley. Then there is a weight going down. This weight C. Weight C equal to mg. MC. C is given 35 kilogram. You have two rope there. Okay, so T. So W equal to 2T. So you find what is your T. You find one of this one. Why? Because this rope pull to here. This T will equal to your force that you use to calculate the motor power. Make sense, huh? Okay. So you try to link the information, then you write in your answer. Okay, you do it slowly, one by one. You based on the information, you derive the equation, then you assembly the information. Okay. Now it asks you to determine the power must be supplied to the motor. Your focus is here and not this one. You focus on here. Okay. So you draw free body diagram on the mass, then you draw the 2T, like what right on the whiteboard. So you can find what is the tension inside the cable. Right? It's half of your W. Okay. And I'm combining F equal to MA diagram. So the one that on the left will be your force, the one that red arrow will be your MA. Okay. Then your datum going down positive. Your datum going down positive. So you need to find your tension, F equal to MA. So your tension equal to W minus 2T. In your statics chapter, you stop at here. But in engine dynamics, you learn something called F equal to MA. Your force no longer constant. Remember, in engine dynamics, your force will always changing when there's a motion. So here, don't stop here. Don't write 0. You write 0 means wrong already. That one is in statics. In engine dynamics, you learn in chapter 2, F equal to MA. Don't reverse back to statics. Static is in equilibrium. You don't have equilibrium in we have lah, but very rarely in engine dynamics. So F equal to MA. So MA here, again, I draw free body diagram, F equal to MA. So I combine two diagrams when we come to chapter 3 already. So A is going down. So from here, you have the first equation. First equation, You don't know the T, you don't know the A. Okay. So how to link the C and M? How to link this one and this one? Through pulley system. Okay, you want to link this one and this one because you're seeing pulley. So go back to the pulley chapter. Okay, so again, start with the total length. Total length of this rope is here plus 2SC, right? Total length. Then the next step, after you find total length, you differentiate with time to find velocity. So the total length change or not? Does the total length of the rope change? No, right? So when you dt time differential this equation, you get 0 on the left. This one, ds dt, and you learn in chapter 1, become velocity. This one become velocity. Rearrange, you get between s and p relationship in velocity. So then you take one more, is acceleration. Because we are more interested in acceleration, one missing here. Because from here, from s become v, you differentiate one more time, you get a acceleration. So AC equal to minus half AP. It means that AC move half the speed, half the acceleration of the P here. Yeah. So we are combining chapter 2 understanding in this chapter 3 question. So once we have that, you know what is your AC, because the question give you the acceleration of P in the question. Right? It was 1.2 meter over second square. Again, a typo error on the slides. Acceleration was given. So you know what is the acceleration of C. Once you know the C, substitute back into equation 1, you should able to find your tension cable. Right? Tension of the cable is 182 point something. For this module, please remain 2 decimal place, maximum 3 decimal place. Unit is accordingly. So this one, tension of cable is in Newton. Yeah, makes sense. Okay, once you find the tension, you need to go back to the power already. You have done all the forces, then you go back to the power equation. You're given the power and efficiency. Okay, power output required to pull at the rate of 0.6. So power of this motor is force multiplied by velocity. So you have the velocity, you have the tension cable here because this cable is the same as this one. The force is the same, right? This cable. So you replace with the T that you find just now. Velocity is given. So you manage to find the power required to draw the cable. Okay. So is 109 watt or Newton meter over second or joule over second. Okay. So this is power output to draw cable. So this power output require the motor to provide input. So you need input and output, right? So this 109 watt is the one that you require to pull this one out. It's the power you need to handle this operation. The question gives you efficiency. Efficiency is output divided by input. So you write the equation. Efficiency equal to output divided by input. 109 is input or output? Output. Okay. So you reverse the things, or you when this one you have, this one you have, so there's only one unknown here. Okay. So you rearrange. The input from the motor is 129 watt. So you need to use a motor that able to work at 129 watt, so that this one can operate as what is mentioned in the statement. because the efficiency is 85%. Make sense, huh? Okay, so to summarize, what is chapter 3 about? Chapter 3 is focusing on the work and power. Work and power, and then efficiency is a repeat of what you learn in your physics. Efficiency is output input. So power is force multiplied by velocity. Work is force must be go parallel with the distance. And there's a principle of work and energy. So far, we work with kinetic energy. So later we look at potential energy. Okay. Now we go to conservation of force and potential energy. Conservative forces and potential energy. We're going to work into P already, potential energy. So what mean by potential energy? Potential energy, we need to refer to a location. So how you define location? You need a datum. Okay, you need a datum. Okay. So conservation of force means that there's no loss of energy, there's no loss of forces. Okay. So work done by the weight is vertical difference of this one divided by spring and so on. So this one is conservation of force. Friction. Another one is friction. When you have friction, when you move a slide at a certain angle, so the longer the path, greater the work. So friction force is not conservative. Friction force, they are not conservative because it depends on the distance traveled. The longer it travel, the longer the friction. Okay, I go back to the previous two. Weight is constant because it can preserve. Weight done by the weight is F multiplied by the distance, right? So it doesn't this one, but the friction depend on part. So friction is not conservative. Okay, now this slide is important when you deal with gravitational forces. Now in this case, look at the datum location. Datum location, above datum we have positive H or positive Y. Below datum we have negative Y or negative H. Datum is very important when it comes to potential energy. The potential energy, you know that is mgh. But the H is depending on the datum that you set in your answer or in the question. Sometimes question give you, sometimes question do not give you. So you need to, if question do not give you and ask you to use potential energy, you need to fix at a certain place. But remember, the one that above datum positive, the one that below datum is negative. Okay. Okay. So in this case, the one that travel above your datum means it's already charged up the energy at a certain distance, positive H, mgh. Right? W is mg lah. Okay, mgh, but it's positive. It's charged up already. But if the object is over here, the distance is from datum to the position. This is negative energy. It's below already. Okay, so this one need to take note lah. Okay, potential energy depending on your datum. Another one is elastic energy. Elastic energy, you know that the energy of the spring give you by Ks square, positive Kf square. So this is unstretched. Unstretched spring don't have energy. When you stretch, this is unstretched. So it will give you positive K square. When you compress it, you will still get positive. Because no matter you pull it or compress it, you are charging the spring. Okay, you're charging the spring when you pull or compress. So the equation for spring energy is always positive. So don't confuse with the spring force. Don't confuse with spring force. This is spring force equal to Ks. Don't confuse with the energy done by the spring. Okay. So this one is, you need to take note lah. This is potential energy. This is work. Work. Don't confuse with the one. Okay. So when you consider potential energy, you need to look at the diagram. Either there's a change of position or there is a spring used in the system. You need to consider these two. So if there's no spring, then you take out the spring component. But usually you have a change of position. So potential energy in chapter 3, you involve gravitational and also elastic or spring. Okay. So the potential energy, we use V. Okay, so V is a combination between two lah. Okay. Same with this one. Okay, same with this one. So if you have a system that with spring and a change of position, remember your potential energy always have gravitational effect and elastic effect or spring effect. So in this case, your datum is here. So your object is here. So it's below the datum. So negative mgh. Negative mgh because it's below datum. And spring always positive in the potential energy. So half Ks squared. Okay. So if the particle move from S1 to a lower position S2, S1 to S2, the work done is V1 minus V2, means position 1 to position 2. Okay, so you elaborate from here. So this is work done equal to the energy. Okay, this energy, this potential energy. Okay, potential energy. In this case, you have two change of position and also spring force. So here, mgh 1 and spring half Ks square 1 minus the second position. So here minus here. You arrive. This one is just a derivation. You arrive and then you substitute the value accordingly. Okay. So this one is a three-dimensional. Three-dimensional, you just work accordingly to the coordinate system. So from x, y, z to x, dy, dx, dz, basically is the same. Only you need to, I work very fast. This one, I don't test you on the derivation. So basically, you convert your equation into x, y, and z. This one, I don't test you in this three-dimensional. Okay, but basically, you convert all the dimension into three-dimensional. Okay, so you can solve in all this. This one you go home and read. Go home and read. So in your future, when you learn about FEM, finite analysis, you will see this inverted triangular. This is partial differential, or in mathematics, 3 or something. You learn about this partial differential, right? It's partial dx plus partial dy, partial dz. Okay. So conservation of energy, it can be combining with conservative and non-conservative. So remember that you, in the whole system, you have conservative and non-conservative. Non-conservative is friction. When you have friction, then you have this one. If you don't have, if you take out the non-conservative, then you only have all the energy before was same with the all energy after. T is kinetic, V is potential. The energy will be the same before the total, before will equal to after. If we use the conservative of principle, conservative of energy, then this is the equation we expect from your answer. You write all the energy before, or you can write T1 plus potential energy 1 equal to T2 plus V2. This also gives you 1 free marks for conservation of energy. Yeah. So this one is just to prove whether the energy is the same. So for example, energy at position 1 will be the same. So position 1, kinetic energy 0, but you charge up the potential energy at a certain h. Your datum is here. The datum here is above datum, so positive mgh, positive potential. So the first position here is 0, doesn't move, plus mgh. You have energy at this location is wh or mgh. At the center here, your h is half but above datum, but there's a velocity there already. Okay, so velocity there, because it's acceleration constant, gravitational acceleration constant, you can use this equation, v squared over something. You substitute back, you can find the v equal to what, right? V equal to square root of your gh at this location, the v. Why we need to find the v? Because you are dealing with kinetic energy, kinetic mv, half mv squared. Take this one. Okay. So at the center here, your energy equal to half mv squared plus mgh. Your h is half. You substitute your v as that one. So you replace your m. You take out the m. Okay. You replace your w equal to mg, m equal to w divided by g. You substitute your m here. Okay. Then in the equation, you don't have m anymore. So you can simplify it, become mgh. It's the same as this location. Okay, energy doesn't change. Under conservation of energy principle. You do the same for the last one. Last one, maximum kinetic energy, velocity maximum, potential 0 because h0 at the datum here. So again, when it's right, also same, you use the Newton equation, v squared over something. You find the velocity at here, right? At the end, you arrive at the same formula, E equal to mgh. The energy does change. This is how you prove it. Okay, this is when you have the only have the potential energy with the change of datum, change of height from the datum. But if the spring, then you need to add the spring inside. Okay. 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 So we will look at this example this Friday class. Okay. So we stop here. Okay. Go to Canvas, enroll yourself in a group for your lab report. Go to Canvas.